The James Webb Space Telescope and the mystery visitor from deep space, one of the most advanced space observatories ever launched, the James Webb Space Telescope, is changing how we view the universe. But long before it began sending back its first images, an unusual discovery had already captured the attention of astronomers around the globe. A mysterious object, unlike anything we had seen before, briefly passed through our solar system, sparking curiosity and debate. This object was named Oumuamua, a Hawaiian word meaning scout or messenger. And true to its name, it arrived silently from the depths of interstellar space, carrying secrets from beyond our solar neighborhood. A visitor from afar. The story begins on October 19, 2017, when a telescope in Hawaii, Pan-STARRS 1, located atop the dormant volcano Haleakala, spotted something moving strangely through the sky. At first, it looked like another asteroid. But as scientists tracked it, they quickly realized this was no ordinary space rock. Oumuamua was moving too fast, on a path that couldn't have come from our solar system. It was the first confirmed interstellar object to be observed passing through. An object like no other. What made Oumuamua even more baffling was its shape and motion. It appeared long and narrow, possibly even rotating like a tumbling baton. Some compared it to a cigar, others to a metallic needle. As it sped away from the sun, something even stranger happened. It began to accelerate, changing its path slightly. This kind of movement is typically seen in comets, which release gases when heated by the sun. But Oumuamua had no visible tail, no outgassing, and showed none of the usual signs of a comet. Its unusual behavior led to a wide range of theories, from natural explanations to bold, controversial ideas. Could it be artificial? Among the many theories, one stood out. What if this object wasn't natural at all? Harvard astronomer Avi Loeb and others suggested that Oumuamua might be a solar sail, a type of lightweight spacecraft propelled by starlight. If true, it could be evidence of technology from an intelligent civilization. Most scientists remain skeptical of the alien probe theory, but the truth is that no current explanation perfectly fits all the observed data. Its odd shape, mysterious acceleration, and lack of a heat signature continue to raise questions. James Webb and the future of discovery. By the time the James Webb Space Telescope, JWST, was launched, Oumuamua had already traveled too far to be observed. However, JWST's powerful infrared vision is opening a new chapter in how we study similar objects. In the future, when another interstellar visitor passes through, JWST could help us detect fine details, such as its surface materials, thermal emissions, and even potential organic compounds. The telescope that spotted it first, though JWST is now at the forefront of cosmic discovery, it was Pan-STARRS 1 that originally detected Oumuamua. This telescope is part of a system designed to watch the skies for asteroids and near-Earth objects, NEOs. In its search for dangers, it stumbled upon something wonderful, a glimpse of another world. A race against time. After its discovery, astronomers had only 11 days to observe Oumuamua before it became too faint to track. A global effort began. Powerful observatories, including the Very Large Telescope in Chile, quickly gathered data on its speed, brightness, and rotation. Some researchers suggested it might be made of solid hydrogen ice, explaining the lack of a tail. Others thought it could be a fragment from a distant planet, shattered in a cosmic collision and flung across the galaxy. Yet none of these ideas have fully solved a new era in astronomy. Oumuamua may have quietly slipped away into the endless void between the stars, but its brief appearance in our skies has echoed powerfully through the halls of science. In a fleeting moment, this strange visitor from beyond reshaped long-held ideas about space, planetary systems, and the nature of cosmic travel. It was more than a rock, it was a revelation. For generations, we imagined space as a mostly empty expanse punctuated by islands of stars, each system isolated in its own gravitational bubble. But Oumuamua shattered that illusion. Its sudden appearance and unexplainable behavior reminded us that the universe is dynamic and interconnected. The space between stars is not a dead vacuum, it is alive with movement. It is a vast, galactic highway, where ancient fragments, rogue asteroids, orphaned comets, and perhaps even the remnants of civilizations wander quietly through the ages. Its visit triggered a collective awakening among scientists. Our solar system, once thought to be relatively self-contained, is now seen as a cosmic crossroads, open to chance encounters with travelers from deep space. This realization has not only sparked wonder, it has redefined the scientific agenda. From this realization emerged a new subfield in astronomy, the focused study of interstellar objects. For the first time in modern science, researchers are organizing around a new question: what else might be drifting through the dark, waiting to be seen? Institutions around the world have begun shifting resources and designing new technologies to spot these rare intruders. One of the most ambitious of these efforts is the Vera C. Rubin Observatory, set to revolutionize sky surveillance. With its ultra-sensitive wide-field imaging system, it will scan the entire night sky repeatedly, looking for fast-moving anomalies that may hint at objects from other star systems. But scientists are not stopping there. Space agencies like NASA and ESA are discussing rapid response missions, dedicated spacecraft that could be launched on short notice to intercept the next interstellar visitor. These missions would allow us to gather in situ data for the first time, analyzing its shape, composition, and maybe even signs of prebiotic chemistry or artificial structures. Imagine a probe catching up to an alien object and orbiting it, sending back high-resolution imagery, molecular data, and possibly samples. This marks a turning point. No longer are we passive observers, staring out into the universe with our instruments and theories. With every technological advance, we step closer to interacting with the galaxy directly, perhaps even communicating with it in ways we haven't yet conceived. A ripple in the cosmic ocean, though small, roughly the size of a football field, Oumuamua created seismic waves in the scientific world. It wasn't just its origin that made headlines. It was the mysteries wrapped in every detail, its unusual elongated shape, its erratic tumbling motion, and its puzzling acceleration as it moved away from the sun. In classical terms, it defied categorization. It wasn't quite an asteroid. It didn't behave like a comet. It had no tail, no outgassing, and no detectable heat emission. Some scientists proposed exotic ideas. Was it made of solid hydrogen ice, slowly evaporating? Was it a fragment of a distant, icy exoplanet flung out of its solar system during chaotic planetary formation? Or could it be something artificial? That final question stirred controversy and imagination. Harvard astronomer Avi Loeb put forth a provocative theory. What if Oumuamua was a solar sail, an extremely thin, lightweight spacecraft driven by radiation pressure from a distant star? Could it be a probe sent by an intelligent civilization? Most experts remain cautious, but the mere fact that such a theory was seriously considered marks a shift in how open science has become to bold possibilities. Oumuamua reminded us that humility is vital in astronomy. The universe often refuses to behave according to our expectations. Each time we think we've mapped its rules, it sends us something that doesn't fit. This object inspired more than debate,